6415. Differentiation is a method used to compute the rate of change of a function fx with respect to its equal x. This rate of change is known as the derivative of f with respect to x. The idea of differentiation is that we draw lots of chords that get closer and closer to bring the tangent at the point we really want. By considering their gradients, we can see that they get closer and closer to the gradient we want. Differentiation is a method of finding the derivative of a function. Differentiation is a process in maths where we find the instantaneous rate of change in a function based on one of its variables. The most common example is the rate change of displacement with respect to time, called velocity. Velocity is the derivative of position with respect to time. Acceleration is derivative of velocity with respect to time. The derivative of the velocity, which is the second derivative of the position function, represents the instantaneous acceleration of the particle at time t. Moreover, derivatives are not directly related or associated with area. Derivatives describe the slope of a tangent line in relation to another line at a given point.
A very good day to Puan Amira. Today I will be presenting for my part on our PBL for Engineering Mathematics. First, I would like to introduce myself. My name is Subhasri Lekha. My matrix number is AA230218. Before I start explaining my solution to problem 2.1, I would like to explain the question first. An airplane is taking off from a runway. Its altitude h in meters at a time t equals t seconds is given by ht equals to 4.9 t square plus 20t. In this question, I am to find three parts of the question, which is the first part is find the velocity of the airplane at t equals to 5 seconds. Second part is to determine the acceleration of the airplane at t equals to 5 seconds. And lastly, to interpret the acceleration in the context of the airplane's takeoff. First, I start off with the equation that is already given, which is ht is equals to 4.9 t square plus 20t. First, I would like to determine the initial altitude at t equals to 0. Therefore, I substitute the value of t equals to 0 into the initial equation, where I get the initial altitude is equals to 0 meters. To answer the first part of the question, I have to find the velocity at t equals to 5. Firstly, I have to determine the equation of velocity by differentiating the equation of altitude. So, the equation of velocity now is 9.8 if t equals to 20. Once I have determined the velocity equation, I have to substitute t equals to 5 into the equation. Therefore, v equals to 9.8 multiplied by 5 plus 20 is now equals to 69 meter per second. To find the second part of the question, where I have to determine the acceleration of the airplane at t equals to 5 seconds, is first by finding the equation of acceleration. To find the equation of acceleration, I have to differentiate the equation of velocity. Therefore, the new equation for acceleration is 9.8. Then I have to substitute t equals to 5 to determine the acceleration. Since in this equation there is no t, the final answer for acceleration at t equals to 5 seconds is 9.8. For the last part, we have to interpret the acceleration in context of the airplane's takeoff. Therefore, the airplane initially has an acceleration of 9.8 meters per second square during takeoff and an increasing velocity from its initial point until takeoff. That is all from me. Thank you.
Hello, my name is Debbie. I'm going to present about problem statement 2.2. A spherical algae in a bioreactor grows uniformly in all directions, affecting the rate at which it absorbs light. The radius of the culture increases at a constant rate of 0.5 cm per day due to cell division. The question is, given that the surface area of the sphere affects light absorption, Calculate the rate at which the surface area of the algae culture is increasing when its radius is 10 cm. How does this relate to the overall efficiency of photosynthesis in the bioreactor system? So first of all, we have the formula of area of sphere, which is area equals to 4 pi radius square, and the given rate of change of radius is 0.5 cm. So here is the solution to find the rate of area if radius equals to 10 cm. dA over dr equals to 8 pi r, and then we insert the values of radius, which is 10 cm, and we get 80 pi. So using chain rule, 80 pi times by the rate of change of radius, which is 0.5, and we get 40 pi. 40 pi equals to 135.67 cm square per day. So this affects the overall efficiency of photosynthesis because the bigger the surface area of the algae, the more exposure to sunlight and absorption of sunlight by the algae. Hence, the rate of photosynthesis will increase each day. Thank you. That is all from me.
My name is Kaishri and from Balamurugan, number metric 88232511. Right now I'll be talking about the phyla tables for question 2.1 and 2.2. Right now I'll be talking about the phyla table for question 2.1. Firstly, altitude function ht equals to 4.9 t square plus 20t. Differentiate altitude to find the velocity. Then review the derivatives and their physical interpretation in motion. And then complete the first derivative to find velocity. Next is time at which calculations are needed. T equals to 5 seconds. Differentiate velocity to find acceleration and then understand the significance of constant acceleration. And compute the second derivative to find the acceleration. Next is velocity function derived. Vt equals to 9.8t plus 20. Interpret constant acceleration in context. Then review how to interpret and apply derivatives in motion problems. And evaluate velocity and acceleration at t equals to 5 seconds. Lastly, constant acceleration is found. At equals to 9.8 meter over second square. Interpret results and ensuring understanding of physical meaning. Next, we are going to talk about phyla table for question 2.2. Facts. The algae culture is spherical. Radius increases at a constant rate of 0.5 per cm per day. The growth is due to cell division and light absorption is affected by growth. Next, we are going to talk about ideas. Light absorption is affected by growth. Light absorption may be depend on the surface area exposed to the light, and efficient distribution of light and nutrients is critical in a bioreactor. Then, mathematical models can help predict changes and optimize conditions. Next is learning issues. Formulas for the volume and surface area of a sphere. Relationships between surface area and light absorption. Mechanism of algae cell division and growth, and impact of sphere growth on nutrient and light distribution in bioreactors. Lastly, action plan. First is calculate volume over time. Apply volume formula V equals to 403 pi r cube with RT equals to 0.5 T. Derive Vt equals to 4 over 3 pi in bracket 0.5 T cube. Second, determine surface area over time. Use the surface area formula A equals to 4 pi r square with RT equals to 0.5 T. Derive AT equals to 4 pi in bracket 0.5 T square. Next is research light absorption. Investigate how the light absorption by spherical objects changes with surface area. And then study specific properties related to light absorption in algae. Fourth, study biological growth process. Understand algae cell division and its impact on growth. Then analyze how cell division contributes to the radius increasing. Next is analyze nutrient and light distribution. Gather data on nutrient and light management in bioreactors. Then evaluate how changes in size impact distribution and efficiency. Lastly, develop mathematical models. Create models to simulate bioreactor performance over time. Then predict efficiency and limitation as the algae culture grows. That's all from me.
Okay, I am Ali Farhan. Today I will present about conclusion. The problem-based learning PBL task use engineering math in real-life situation. The airplane take-off problem, we use calculus to find the velocity and acceleration at a specific time. This shows us how important differentiation in understanding motion. Secondly, problem about algae growth. We look at how the surface area affects growth using calculus. We calculate how the surface area increase, which with the photosynthesis, this showed us how MEC can optimize bioreactor performance. Lastly, this does not only strengthen our theoretical knowledge but also give us practical skills to solve engineering problems. They show us how mathematical models can predict and improve system efficiencies in engineering. Okay, that's all.